In this problem, we're looking to sketch a graph, and we have a piecewise function here. We've got three parts to our function. If x is less than or equal to 0, then our function is 1 plus sine of x. If it's between 0 and pi, it's cosine of x. And last of all, if x is bigger than pi, then we've got sine of x. Once we have our graph sketched, we're going to figure out where the limit as x goes to a of f of x exists. And since trig functions we know are always going to be fine for limits, the main points that we want to worry about are these points at 0 and pi, for which we're splicing together this graph, and we want to ask ourselves, are those points going to be broken, or are they going to be coming together and we're kind of stitching them together in a way that makes that limit work? All right, so again, here is our function that we're working with. The first thing that we want to do is we want to figure out, what do our base functions look like? And these are things that we should have in our head when we work with graphs like this. So there's two base functions in this particular case. The first one is sine of x, and we know that sine of x looks like this. So here y is equal to sine of x. Here's pi over, or 2 pi, and here's pi, and we can kind of chop up the graph anywhere we want. We're going to actually use the idea that this is what our sine of x graph looks like in order to look at what 1 plus sine of x looks like. In particular, we're going to notice everything's going to shift up by 1 because our y value, our output, is going to be adding 1. All right, the next graph that we want for our base function is we want our cosine function. And that is the other one that, normally I don't recommend memorizing things for math classes. The goal of a math class is so that you can figure things out without having to memorize things. But this is the other one that I would recommend. This is one of the few things. Here's cosine of x. And again, we have, okay, here's 2 pi, and here's pi. And we can use this, again, to work with, we notice in that, to work with our function. So we know cosine of x is between 0 and pi. So basically, we are going to be popping this part of our graph into our final solution. All right, so let's put these together. We're going to start off by drawing a picture. So we want our xy axis here. And we also want to know where pi is. So I'm just going to pop pi right there. We know already, we just talked about where our cosine of x looks like. I'm going to do this in a different color. We know that cosine of x, if we go back here, it starts at +1 and then it goes to -1. So that is what our graph is going to look like here. We're going to start here and we're going to go down there. And we are also going to keep in mind that when we're doing this, we have closed points on both the top and the bottom there. And that is because when we look at our inequalities here, we have the underline on our middle graph, our middle function, cosine of x. So x is less than or equal to 0, and x is less than or equal to pi. So those are both concluded. Now, we know what our second graph is going to be, this sine of x that we want to piece in. And we know that's going to work when x is less than 0. Let's go back to our base graph here. I'm going to extend this a little bit on the other side. Notice, if we extend this, it's going to, of course, have that same shape. So let's see, here's 1, here's -1. We are going to be starting here and then going down and then back up. However, this is sine of x. Our actual function is 1 plus sine of x. So we're going to shift that up, and instead of starting at 0, we're going to start at 1. Technically, that should be an open circle. And it's going to go down, and then it's going to go up and over, up to 2. And I do apologize for a little bit of a because it is going all the way up to 2, and it keeps on going. Now, you'll notice that in the middle of these two elements here, they match up exactly. And so we know we're going to be just fine for continuity and our limits right there. The next one is, and our last one is sine of x if x is bigger than pi. So let's go back and look at our graph here. Sine of x for x bigger than pi, that is this part of the graph right there. So it starts at 0, goes to -1, and then just keeps on going. So if we pop that into our graph, we are going to start at 0, and we need an open circle there. And it's going to go down, and then it's going to keep on going. All right, so what do we notice? We notice that there is this big jump here in our graph when we are at pi. So that tells us in our solution that the limit as x goes to a of f of x exists everywhere except at x is equal to pi. So anytime you have to take your pencil off the paper completely and move it somewhere else, your limit is not going to exist there. Only one-sided limits, that means coming in from one side or coming in from the other side, are going to exist, but coming in from both sides, they do not meet to the same spot. So our limit does not exist at that point. Thanks for listening.